Welcome in. So showing the derivatives of cosecant, secant, and cotangent. So how do these particular derivatives come about? That's the goal of this video. Now I will make an assumption here is that you are familiar and you understand what the derivative of sine x is and the derivative of cosine x. So just a reminder that if you wanted to take the derivative of sine x, everyone should know, watching this video, that the derivative is nothing else but simply cos x. And if you want to take the derivative of cos x, then you should know that the derivative of cos x is simply negative sine x. Once we have these two derivatives, to be honest with you, you can derive any other derivative in the trig functions that you're going to run into. Now here, I'm going to talk about cosecant, secant, and cotangent. If you wanted to see how the sine and the cos derivatives have come about, I'll put up a link up above there, as I did a video on that relating those two derivatives. All right, so first of all, if I'm going to take this, how am I going to show this? So let me just paste it down below here. So this is our goal that we want. And what I want you to think about and recall that if you take cosecant, this is nothing else but simply 1 all over sine x. That is the actual definition of cosecant. We just write cosecant for convenience. Now, if that is the case, well, we can certainly take the derivative of this. And if I do take the derivative of 1 over sine x, I can then think about of saying, well, this is just simply sine x, okay, to the negative 1. And for that, well, I can think of composite functions and then just simply apply the chain rule to be able to find out what the derivative is. The derivative of the sine x to the negative 1 is nothing else but simply the application of the kind of chain rule for composite functions. We have a negative 1 as an exponent, and, well, we are very comfortable taking derivatives of a function which is raised to an exponent. So this is going to be nothing else if I take the derivative, but simply negative 1 multiplied by the function, and that exponent is going to be negative 1 minus 1, which is just negative 2. Now, of course, I still have to take the derivative of whatever is inside, so I have to take the derivative of this function by the chain rule, while the derivative of sine x, as we have shown right here, or at least mentioned it here, is just simply cos x. So this is going to be multiplying by cos x. So that's the derivative. Now, from here, how do you obtain this right here that we have? That's a little bit of massaging. So let me massage this out. So what does this equal? Well, I have negative 1, and notice I have the cos x right here. This sine x is nothing else but simply sine. So this is if you bring it to the denominator, you can use the exponent rules. So that's going to be just sine squared. And with this, you can see, I hope you can, that this is simply cos x all over, and now you can put sine x times sine x, right? So that's from here to here, that's what you would have. And now for that, if you wanted to obtain, so this right here, well, this isn't really difficult because of the fact that we have, this is cos x over sine x. Well, cos x over sine x is simply cotangent, so that's what I have there. And then that leaves me the sine x here all alone. And 1 over sine x is, again, just cosecant. So this comes back and is simply negative cosecant x multiplied by cotangent x. So that's one of the derivatives that you can think about in terms of showing what that cosecant of x and what the derivative of this is. Now, you can see this in many different forms. We could have just left it right here. We didn't have to actually proceed So I could have just left it as it is right here. And I could have also written this out if I wanted to, because you have negative cos x over sine squared x. So this can also be known as simply as negative cos x, and this would have been cosecant squared x. That's still the same thing. It's just a matter of trig identities and playing around. Which one you choose is up to you. This one is kind of the one which is most of the time utilized, but not necessarily. It will depend on what you do. For myself, I actually try not to really memorize these. The only ones that I do memorize, okay, are these two. So because once you have these, you can then derive any really trig function that you want in terms of its derivative. So that was the first derivative, and that's how you can find it. Now, what about the second one? So let's take a look right here at the derivative of secant x. Now that you have seen the actual derivation of cosecant, I would encourage you, pause the video and see if you can do exactly the same thing as I did, and then just play the video back and see if you actually found how that particular derivative can be found. So this is what we're looking for. I'm going to use the exact same trick here as I'm working. So, well, secant x is nothing else but 1 over cos x, which again is just simply cos x. This is to the negative 1. And taking the derivative here will be simply negative 1 multiplied by cos x. This is going to be to the negative 2. And now I have to multiply by the chain rule, by the derivative of what's inside. So that will be just simply negative sine x. The negative and the negative will cancel. And what I will have is I'm going to have sine x all over cos squared x. So this is equal, again, either to sine x, and then cos is nothing else but secant squared x. So that's one way of writing the derivative. Now, if you want it in this particular form, well, that's not a problem. This can simply be divided into, so notice what you have is you can have 1 over cos x, right, multiplied by sine x all over cos x. This is just simply nothing else but 10x. And this right here is nothing else but secant x. So that is exactly the derivative that we were looking for. That's what you would have. And that's just manipulating and knowing and remembering what the derivative of cos was, really, and then applying a chain rule from the derivatives that we have learned in the past. Now, if you've forgotten about the chain rule, I can always put up a link up above there if you wanted to go back there and then see how that chain rule comes about and how to use it. The last one in here that we have is cotangent. This one right here. So again, you can pause the video and see if you can derive on your own, now that you have seen several examples, this particular derivative. This is what I'm going to try to do. I'm going to take my cotangent. I never like to work with cotangent or try to memorize its derivatives, to be honest with you. I'll always think about it in terms of just cotangent is nothing else but cos x all over sine x. That's just by definition. So that's the reciprocal of tangent. So with this, if you wanted to now take the derivative, you can use the quotient rule. And with the quotient rule, you can just simply go ahead and apply. So I can take the derivative of the numerator. Well, cos x is nothing else but negative sine x. You multiply it by the denominator, which is just sine x. Now you subtract by the quotient rule. This one will stay the same, so it's cos x. And now the derivative of the denominator, which is also cos x, all over. So as you take this, you will now take the denominator and square it. Well, squaring the denominator creates sine squared x right here. That's what I would have. Now this, or manipulating this, I can take out the negative from both. And then I'm going to get sine x squared plus cos squared x all over sine squared x. But what is this? It's just kind of from trig identities, or really not even trig identities. This is kind of how our sine squared plus cos squared, in terms of our unit circle, the way that we define things, the Pythagorean theorem, this is just equal to 1. Again, if you forgot about that, I'll put up a link up above there. So this is now simply -1 all over sine squared x. Well, that's just negative, and then sine is nothing else but cosecant squared x. And there you have your derivative. So that's interesting. Now, as I mentioned, I don't really memorize these at all. It is up to you. Now, if you're going to be using this, and as you're kind of getting into calculus, you probably will memorize, especially as you keep doing and practicing these derivatives over and over and over again. But whenever in doubt, especially on tests, quizzes, or anything like that, my suggestion to students is, try to maybe memorize this and try to memorize this. And then when in doubt, when you are dealing with these, just remember the actual definitions of cosecant, secant, and cotangent. If you have done that from grade 10 and grade 11 and grade 12, for example, advanced functions, you'll be fine. Then deriving these derivatives should not be that bad. Of course, that's easier said than done. But now that you've watched the video, I encourage you to try to derive these again from scratch and see if you can do it. All right. Thanks for watching, and we'll see you in a future video. Happy studying, everybody. Bye.